All right, this is Group 5. My name's Alec.
My name is Victor.
I'm Ryan.
And I'm Adam. Today we're talking about
Fusion. All right, now some of you might be wondering, what exactly is fusion?
Fusion, by definition, is the combining of lighter atomic nuclei to form a heavier nucleus when energy is released.
A common form of fusion is shown in the diagram here between two isotopes of hydrogen, which are combined to create helium and heat, which is used for energy.
On the other hand, fission is different than fusion, as fission is the process of splitting heavier atoms' nuclei into lighter parts, while fusion is the joining of two nuclei into a heavier atom.
So what is the problem with fusion?
Well, there are three main points of producing these reactors that make it difficult. Two are the enormous size and cost of each reactor, which makes it difficult to mass produce, and the sheer amount of energy that is required to get the process started is also difficult.
Fusion is currently inefficient because the amount of energy required to start a fusion reaction is much greater than the energy it produces.
There are very few safety issues with fusion, but the one major one could be that if the containment was destroyed or damaged in the process, then the radioactive and the heat that's inside the reactor could
be dangerous. Why do we need fusion?
We need fusion because other current energy sources are inferior to fusion's potential.
In 1 kilogram of fuel used in a fusion reactor, 7,265,664 kilowatt hours of energy is produced. That's a whole heck of a lot more than what we produce today. Beat that, gasoline.
Fusion will also allow energy to be available at a decrease in price and an increase of availability to consumers.
Current nuclear reactors need improvement because the potential for disaster with current reactors is greater than that of the potential fusion reactors.
Yeah.
So what are some potential solutions? Scientists have been working on the W7X stellarator, the ST40 spherical reactor, and the TAE accelerator supplemented reactor.
W7X stellarator is a large donut-shaped fusion reactor built in Germany. It was successfully powered on and functioned in 2015. It shows promise, however, it was 20 million degrees Celsius short of the 100 million degrees Celsius needed to complete the reaction.
ST40 is a compact spherical fusion reactor which utilizes HTS or high temperature superconductor technology to increase the magnetic strength and decrease operating temperature. The increase in magnetic strength solves the problem of having high heat energy needed and holds the plasma in place. This will allow the potential to bring widespread commercialization to the near future.
The third potential technology is the accelerator supplemented reactor, in which energy is injected using a particle accelerator. This type uses boron-11, which does not produce damaging neutrons, which would help costs with repairs not being required. But this technology is less stable and more vulnerable to outside forces because it doesn't have a magnetic field that protects the energy.
Sources. These are the sources. Thank you all for watching. Goodbye.